The practical way of measuring electrical properties is using a digital multimeter. A digital multimeter, or DMM, is a combination of an ammeter, which measures current, a voltmeter, which measures voltage, and an ohmmeter, which measures resistance. We will go into further detail how to use this in the further slides. The most common application for using a digital multimeter is using it as a diagnostic tool. When something on your circuit is not working right, or you need to check values at a particular point to make sure that they're regulated the right way. The more high-end models can measure quantities such as frequency, temperature, conductance, inductance, and so on. Here's a very basic example on how to use a digital multimeter to measure total resistance. So each multimeter has a positive and negative probe to it. So the only thing you need to do to measure total resistance is to place one probe on one end of the resistor and the other probe on the other end of the resistor. Here are some examples on how to measure series and parallel resistance as well. Essentially, it's the same method, just in a different position. So to measure series resistance, you just place one probe at the one edge of the series combination and the other probe at the other end of the series combination. With parallel resistances, since they're connected at the same point, it's fairly easy to find out which edges that you need to place at. But essentially, the same goes for this. One probe at one edge and the other probe at the other edge. A common tool used to practice building electrical circuits is a breadboard. The advantage of this is that you can build things quickly and it doesn't require any soldering. And most of all, you can still salvage and use the parts later. So here is an illustration of how the breadboard is actually wired inside. So these edges of the breadboard are called rails. These are usually used to connect the positive end of your battery, positive and negative ends of your battery. So the positive will be connected there and the negative will be connected there. So you have easy access to your voltage supply no matter where you are in the circuit. The thing that you should take away is that for the rails, each of these points across this vertical line are all connected together. Same with the black. Each point across this black line are all connected. Now the opposite is true for the points inside the breadboard, which are used just for connections. So these points on the breadboard are connected horizontally. So you can also think of each horizontal combination of points as one node. This space here breaks the horizontal combination so that this point and this point are not connected. So again, here's an illustration of some devices that are being connected. This is an LED. So LED is connected to the negative rail or the ground terminal. This resistor here is connected to this LED because they're both on the same horizontal row. And the edge of this resistor is connected to the positive rail of the voltage supply. So if we were to draw this schematic, it would look something similar to this. Voltage, which is connected to a resistor, which then connects to a LED, which connects it back to the negative terminal or ground. So if you want to measure resistances at home with your digital multimeter, I strongly suggest that you measure experimentally first so that you know that what your DMM is reading is correct. So here are just some basic combination of resistors. This one is in series. This one is in series, so you should get 2 k ohms. And this one is in parallel, so you should get 2 times 2 over 2 plus 2, which is 1 k ohm. Here's another more complex example for you to solve for yourself. This looks very complicated, but you can still just as easily measure the total resistance across them with your digital multimeter just as easy as you could with a simple 2 resistor series measurement. To experimentally calculate this, we would start from the right and work our way left. So we would start with this branch of resistors. And we can tell that since they're only connected at one node, that they're in series. So this then becomes so this is 1K plus 1K. So this becomes 2K. 2K, 1K, 2K. Now if we go back to identifying nodes, we can find a node here and we can find a node there. So this 2K is in parallel with the other 2K. So if we find the equivalent resistance of these two, this 2K with this 2K, we can reduce it to a simple form of this 1K, 1K, 2K. So all of these, if we produce current, the same current will flow through all 3 of these, so they will all be in series. So the total resistance equals 4K. A practical application of this is when you have an unknown resistance, an unknown variable resistance, you can create this, which is called a Wheatstone bridge, to find the equivalent resistance within your circuit. So now that we know how to measure electrical properties, we can start to build a complete circuit. So here's our battery, here's our LED, and here's our resistor regulating the current. So the current flows through this battery, through the resistor, through the LED, and back into the negative terminal of the battery. So as we've seen before, the voltage at this particular point is 9 volts. So typically the voltage drop across a parallel resistor in a battery would be the same voltage, or 9 volts. But because this LED requires some voltage across it, say 1 volt, there will be some potential here at the other end of the resistor, which is 1 volt. So because of that, to find the voltage drop across the resistor, we would need to subtract 9 volts minus 1 volt to get the voltage drop across, which is 8. As we referenced to earlier, the multimeter is not just used to measure resistance, but it also can be used to measure voltage and current. If you look at the picture above, if you don't have a digital multimeter yourself, this knob here allows you to change the function to which you are being measured to. So depending on what property you want to measure and the order of magnitude you believe that value to be, you can change the function of your digital multimeter to measure that value. For example, if you are measuring some sort of voltage across a 9-volt battery, you might want to change the dial to 20 volts because that's an approximate order of magnitude to which you're predicting the value to be.